Thelma, for the kind introduction and for the invitation. It's actually an honor to be here today, as when Dr. London Wadicott invited me to speak today, it was such a cool moment because when I was a student at Kansas State University, she was one of my mentors. And so kind of full circle now, and I so much appreciate it. And I'm so excited to be here and to share a little bit of freeze drying, some of the food safety considerations on freeze drying. So thank you again for the invitation, and also to be here to connect with all of you today. Let me share my screen. Can you all hear me well? Let's see. Can you see my screen?
Yes, we can.
Perfect. All right, so again, my name is Carla Schwan, and today I'll be talking a little bit about the food safety considerations of freeze-dried foods. And throughout this talk, I wanted to bring and look at some of the microbial survival that happens during freeze drying, and also explore some strategies and best practices for preparing, for handling, and storing freeze-dried goods. Okay, all right. So for today's agenda, we'll start with preservation of food and microbes. And you saw that, right? As we are also preserving microbes. And some of the concepts that are applied in preserving food, but also the same concept kind of transfer over on preserving microbes as well. Then we're going to go into the freeze drying process and what it is. Some food safety considerations and some key points to keep in mind when freeze drying food at home. And this is more from a little bit from the consumer perspective. And then finally, some resources, looking educational resources that are available around this topic from agencies and also land-grant universities. So in order for us to extend the shelf life of a product, it is important to control the microorganisms that are present in that food, right? And so some microbes are present intentionally, like in cheese and yogurt, but some are there they can cause spoilage, and some are there can be harmful. And so in order for us to control the growth and survival, I should say, of those microorganisms that can be harmful, we need to understand what are the factors that we can control and the factors that we can modulate or even change in a food product, in a food matrix, in order to prevent them from growing and surviving. And so these factors are the food source, so what type of nutrients or what nutrients are available in that food source for the organisms to grow and survive. The acidity of the food, so which we often measure as a pH, the temperature, and the ideal temperature for microbes to grow, what it is, the time, and how quickly microorganisms can grow and multiply, oxygen requirements, do they like oxygen or not, and then finally, moisture and how much water is available for the microorganisms to use. And that is usually measured by water activity. We measure water activity, and that's how we relate it to the available water in the food. And I just want to point out, it's not the water content or the amount of moist that is in that product, but rather how much water is available. And available is really the key word here for this. And because freeze drying, the process of freeze drying, we are going to be manipulating the water activity. I'm going to zoom in into the moisture, the water activity that is in the food product and some of the concepts when we talk about that. So what is water activity? As I kind of already alluded to in my previous slide, water activity is the measure of the amount of moisture, the amount of water that is available. And I put this here kind of underline because it's really the key word here that is for the microbes to use. So keep in mind that it is different from the amount of water or the percentage of moisture in a food product. And water activity is usually measured on a scale, not usually, it's always measured on a scale from 0 to 1, where you have distilled water as an example, is pure water is going to be 1. And all foods are going to be below 1 because, of course, it's not pure water. You have a mix of different things. So all the food values that you see are going to be below 1. So microorganisms will have a minimum water activity for their growth and survival. And here in this table, you can see how much this value is needed in order to support their survival and growth. And so, for example, here, if you focus on E. coli, you're going to see that it requires at least 0.95, while a mold like Aspergillus, it requires only 0.8. And so if you think about jams and jellies, Sometimes you see mold growing, and I guess I should say jams and jellies, they have a relatively low water activity despite having a lot of water and despite of it being very moist. But what changes in this scenario is that jams and jellies, having a low water activity, that water is bound to sugars or pectin. And so bacteria, which require a higher water activity here, as you saw with E. coli, compared to molds, you're going to see some mold growth in jams and jellies, but you probably are not going to see bacteria growth in jams and jellies. So that's why, because this minimum requirement, this minimum value is what is driving that. So we already know what water activity is and how we can change that, but how can we manipulate and change that in food? And so we can then prevent the growth of microorganisms in food by manipulating water activity. And of course, there are other factors that I mentioned earlier, but for the purpose of this talk, water activity is really, really important for freeze drying. So, well, we can change the state of the water that is present in the food. In this case, we can freeze it, even though the water is going to still be there, but it's going to be frozen, so microbes cannot access that water. Therefore, they cannot grow. Or we can evaporate it, and therefore the water is gone. Of course, they cannot use. Another way, we can bind the water to other compounds. I kind of already mentioned that with the examples of jams and jellies. The water then is bound to sugar, is bound to pectin, and even though it's a high moisture product, the water available is little. And so those are some of the ways that we can manipulate water activity in food as a hurdle to prevent microbial growth. So does freezing or drying eliminates bacteria? Yes or no? And you probably already know the answer. The answer is no. It does not, but it can inhibit their growth. So that's a good thing, right? At least to begin with. So by freezing a product, we temporarily prevent the microbes from using that water because it's frozen. But once that product is thawed, then the water becomes available again, and then the microbes are able to access that water and use that water and grow again. And by dehydrating or by drying a product, we are removing that water from the product, and therefore there's no water available for the microbes to use. They are still hanging there, but once that product is rehydrated, then we are giving that water back to them. If the product was contaminated, then they can use that water and grow again, and if it was a pathogen, cause disease. And so neither freezing or drying completely eliminates bacteria, and some bacteria can even become active again once the conditions are favorable, once that water is back. And of course, this is a very generalized example. There's other factors that affect the safety as well, but for freeze drying, water activity is one of the main ones. And so keeping this in mind, just to kind of illustrate the point a little further, do you all remember last year, and even this year, we already have too, some outbreaks and recalls with flour, black pepper, and frozen goods. So salmonella outbreak that was linked to flour, some recalls with black pepper and salmonella. And so black pepper and flour, they have extremely low water activity. They're very dry, but despite having a low water activity, salmonella is still able to hang out and pathogens are still able to hang out there. And once conditions are favorable again, they can grow and cause disease. And that's why we see some of those. Also with frozen fruits, in this example, strawberries, you can see it was a virus, so hepatitis A, but also norovirus we have seen as well, that even though it was frozen, nothing was happening. By the time that that product was thawed and no intervention was applied, no cooking step was applied, the virus was present, it was able to be active again and get people sick. So now that we have seen that freezing does not eliminate, drying does not eliminate, guess what happens when we combine both freeze drying? You probably already know the answer. It does not eliminate pathogens. In fact, we use freeze drying to preserve bacteria in the lab. How crazy is that? So now I want to move a little bit into the freeze drying process so we can understand a little bit more how this process allows not only the food to be freeze dried and to be it retains the original shape of the food and nutrients and flavor and all of that, but also how this process helps the microbes to be stored, because we do freeze drying process for bacteria in the lab, and we can store them at -80 for years. And once we rehydrate, we give them the right food, they're able to grow right back in, and we're able to use them. So here in this figure, on the y-axis, we have the pressure, and on the x-axis, we have the temperature. Also, in this figure, you're going to see there's different states of water. So here in this little corner here, we have water as a liquid state. Here we have water as, freezing or frozen water or ice. And then finally, on this corner right here, we have water as a steam or vapor. And so during the freeze drying process, what happens first is that the item or the product is frozen solid. And so you can see that, the water that is inside that product is frozen very quickly and to very low temperatures, and is frozen solid. Then the next thing that happens is that we drop the pressure, or we create a vacuum inside that chamber by using very low air pressure. And because we are doing that, we have dropped this pressure, and now we apply a little bit of a heat, and we can warm that product up again. And then we are eliminating that water by sublimation, which is directly from ice to vapor. And so in that is, we can do that because we are here in the center. You can see this is a triple point of water. And when we do freeze drying process, we go a little bit, just a little bit below the triple point of water, which is at specific temperatures and pressure, the water can exist in all three states. So liquid, frozen, and steam. And because we are just a little bit of below the triple point of water, we can go directly from ice to steam and skipping the liquid stage. And so because we do that, and it's a very gentle process on removing the ice crystals to vapor, remember, we freeze them very quickly. So the ice crystals to begin with in that food product, they're very small. And so by removing those ice crystals gently, by warming this process up a little bit, we are able to retain the shape of the product, the color, the nutrient, everything looks really, really good. And so does bacteria, because the ice crystals that are formed inside that tissue, they are small, they're not puncturing the cell wall. And, in the case of vegetables, the water is not leaking and you don't have, a mushy product. Rather, it retains usually the original shape. The same thing happens with bacteria. We are able to remove the ice crystals very gently. It does not disrupt the cell wall of the bacteria, and DNA does not leak out. That's why they don't die. That's how we preserve them. And so the same way that we are preserving food, we are also preserving pathogens if they were present. And I'm using a lot bacteria because that's what I work with, but also viruses, they work very similarly. It's a similar concept. So now looking at a little bit of some of the food safety considerations, let's look at food safety 101. And this is usually something that everybody's tired of hearing: cleaning surfaces, cleaning countertops, utensils, trays, washing hands. But really those two very simple steps, and they don't really cost much, can prevent cross-contamination on the front end even before you start the freeze drying process. So once surfaces and equipment and trays and hands, everything is cleaned, the next is we're going to focus on the product. And so how do we ensure that the product is ready to be freeze dry and the product is safe? So sometimes there are steps before the freeze drying even starts. And so, for example, for produce, produce should be washed, sometimes even peeled and trimmed, depending on the situation, depending on how that recipe was developed. And for produce, is always a good reminder, you do want to wash it and not soak it in water, and wash it in clean running water. In addition to the safety portion of it, the quality portion of it too, a lot of different vegetables and fruits, they require pre-treatments to avoid, becoming soft due to enzymes or changing color due to enzymes. And so this is all happening before the freeze drying even takes place. So this is just an example of quality preparation steps before the freeze drying. And I'm not going to really go over the steps here, but I just wanted to show you an example that always comes to my mind is when you slice apples, for example. if you don't do anything to it, they're going to become dark. And so to avoid that browning, darkening of the apples, you can do several different methods, and those are just some examples that you can choose from. Those resources are also available at the National Center for Home Food Preservation if you want to check out later as well. I have some resources at the end, but I just wanted to show you that even before freeze drying, there's some things that you would need to do in order to preserve the quality of the food. Now, looking at the safety part of it, in case of home slaughter or game meats, they need to be treated for parasites, either by pre-cooking the meat or by freezing it for the recommended amount of time in this case. So, but you're probably asking yourself, but Carla, during the freeze drying process, there is a freezing portion of it. Does that not kill the parasites? Can we not just do that instead of doing this before? And I'll say it might, but in the case of trichinella worms, it really depends on the temperature during that freezing portion of the freeze drying. And sometimes it might not eliminate the trichinella larva. And so this table here is just a little summary of what USDA recommends if you have a home slaughter or game meat that you are intending to freeze dry if you are not doing any pre-cooking, for example. This is an example or a summary table for freezing, depending on how thick the meat that you are doing is for freezing it or for freeze drying it. And so depending on the temperature during the freezing portion of the freeze drying process, it might not eliminate the trichinella larva. So really, really important. Trichinella larva can be killed instantaneously at -35. However, if you choose to go with a protocol that is lower than that, because however the recipe was tested, I would say it's always a good idea. Do the pre-treatment before to avoid any type of trichinella larva or trichinella worms in your product. So now we saw everything, not everything, but some examples of the before the freeze drying even takes place. Now, after that, as important as it is to begin with, it is as, finishing it. So again, washing your hands with soap and water for 20 seconds after you handle raw meats and eggs, cleaning the utensils, the surfaces, the equipment, and also not forgetting the trays. There are some steps on how to clean and sanitize at the end that I shared. So I'll provide those resources. So if you want to learn more what those steps are, you can definitely check those out. Storing raw meat and eggs away from ready to eat food. And in this case, if you have raw freeze-dried chicken and washed freeze-dried strawberry, they might not even be stored together to begin with because maybe the flavor, people are, it's kind of, I don't even know which word to use, but it's kind of natural that people would put chicken somewhere else and freeze-dried strawberries somewhere else. They're separate, right? It's kind of obvious that. However, if you think about raw freeze-dried chicken and cooked freeze-dried chicken, and when I say raw and cooked, I mean before the freeze-drying even takes place. Let's say you had raw freeze-dried chicken that you freeze-dried. It's still raw despite being, despite going through the freeze-drying process. However, if you cooked your chicken before you did the freeze drying, now it is a ready-to-eat product because you already cooked that chicken before you even freeze dried it. And at the end of the day, you're going to have chicken and chicken. One is raw, one is cooked. And so consumers might not realize that even though it's the same product, but they are two different things and they should be handled differently. So just as a reminder. And finally, if you do have raw, freeze-dried meats or eggs, for example, cooking it to the correct internal temperature is always super, super important to avoid foodborne illness. And here is just a chart from the CDC, but other institutions, other agencies provide those as well. I also included that at the end as resources. Now, looking at storage, there are several options to store your freeze-dried goods, and it is important to store it in the right conditions with the correct packaging, right? So some examples of packaging here that I included are glass canning jars, metal jars, Mylar type bags, vacuum packaging, just regular plastic storage bags. And each option has the pros and cons, which I have also included resources at the end if you like to learn about the pros and cons of each option at the end. So Penn State has some great resources on this. And in addition to the packaging material, there are other things that we can do to increase the shelf life of that product. And one example that I want to bring here today is the oxygen absorbers. And so really oxygen absorbers are just small packs that really they just absorb the oxygen and they reduce the oxidation inside that package, increasing the shelf life. So one point that I really want to emphasize is once the freeze drying process is done, how much time you take to package that food product and what environment you are storing it, but also what environment you are living in. For example, in Georgia, it's really humid. So when you are done freeze drying, you have to immediately pack it and be very, very careful not to let that product sit there for, maybe an hour and that product's reabsorbing the humidity. And so super, super important also where you're going to store the location of the bags afterwards. And it is important to pack it quickly, store in a cool, dry place with minimal heat and exposure. And in the next slides, we're going to see why, more from the microbial perspective on what could happen. So there are two main types of oxygen absorbers, one that will reduce the oxygen levels and one that will reduce the oxygen levels, but will increase the CO2 levels, right? So let's look at the first one. So if freeze-dried is not done properly, there can be several concerns with the type of packaging, the type of oxygen absorber that we choose to put into that package. So reducing the oxygen levels without any intervention and putting that in a closed container, it's already a concern for Clostridium botulinum, the bacteria that produces the toxin and causes botulism. So, but if you correctly freeze dry your foods, you have a very, very low water activity, and this will not support the growth of Clostridium botulinum under normal circumstances, and you are good. You don't have to worry, right? However, if the process of packaging is not done correctly or the temperature of storage is too high, you run the risk of generating moisture or condensation inside that package and increasing then the water activity, which was low. Now you are increasing that water activity. And now in this scenario, you could have a higher water activity and potentially Clostridium botulinum would be able to grow because now it's an anaerobic environment, higher water activity, ambient temperature. Now it could be the perfect scenario for Clostridium botulinum to produce the toxin and cause disease. So this is the first point I wanted to make. The second one, remember there's two types of oxygen absorbers that are commonly used by consumers. The first one just reducing the oxygen, the second one reducing the oxygen but increasing CO2. In this case here, if you have an oxygen absorber that will reduce the oxygen, obviously, but will increase CO2, will have a problem with Clostridium botulinum in this case, if the conditions are right. And Clostridium botulinum is not inhibited by elevated levels of CO2 in this modified atmosphere packaging here. In fact, there's research showing that the growth of CBOT can be stimulated by high levels of CO2. So this technology is great using CO2, oxygen absorbers, or, depending what type you choose, but it has to be used correctly. This is the main point I wanted to make. This technology is great. It will help to increase the shelf life. It will help to, the quality of the product. It is available to use, but when we talk to consumers and we share this information, it's super important that we tell them how to use the oxygen absorbers properly, when to use it, and what are some risks associated if they choose not to follow some of the recommendations that we provide. And so I'll finish this part with this message, and now I will share just some really quick resources that provide research-based information around this topic. So universities and cooperative extension service in general provide research-based information in several food preservation methods, including freeze drying. Here I included the National Center for Health Preservation, some of the pre-treatments that I mentioned for quality, but also safety we have available in the website that you can check out and learn more. In the next few slides, I have included other universities and other agencies that have information that is pertinent to freeze drying, but I'm sure I have missed some of them. So this is not a comprehensive list by any means. This is just a starting point if you are interested in this topic and if you want to learn more. So you have the Ohio State University, Penn State Extension, University of Idaho, University of Minnesota, University of Maine, Iowa State University, Utah State University, foodsafety.gov, USDA, Clemson, FDA, and CDC. And again, this is not a comprehensive list. This is just some examples to give you a start head if you want to learn more. Some references. And with that, I thank you for your time, and I'll hand it over to my colleague, Melissa.